pathetic.
Yeah, thanks a lot. Thanks for having me. It's a privilege of staying here as a fan, which is really good. So I will start. So what can I present today? I will give a short introduction for sure. I will give you an insight into aviation, the state of aviation today after COVID crisis. It's increasing again. I will address a specific use case for supply chain management within aviation. And there is a couple of challenges in the supply chains, and how can we address those challenges with Neo4j. And for sure, we have discussion and questions afterwards. So first of all, who am I? Jan Frieling. I have a background in business information science. I've been working for Airbus for almost 10 years, and I'm with Supersteria for 11 years now. Basically, I'm dealing as a so-called service line manager for mainly two services. One service is virtual product management, so how to bring the product in the product lifecycle across all this life cycle, especially for 3D data, but for other metadata as well. That's one main service. The other one is data science, business intelligence. So, what is Supersteria? Not everybody might know Supersteria. It's a very big French IT services supplier. So we are more than 50,000 people worldwide, focus on Europe and India. We are dealing basically with banks, insurances, and public sector. So not exactly the focus we have today, but there is a dedicated vertical, a vertical called Aeroline. So what is Aeroline? Aeroline is roughly 10% of this group. Main customer is Airbus Group and some others and its suppliers. So Aeroline is more than 5,500 people, again across Europe. A little bit, we just started in America, in Canada, and we have a lot of people in India as well. To make it even more complex, I'm not directly at Aeroline, I'm at Simpa. So what is Simpa? Simpa is a subsidiary of Supersteria, dealing mainly with product lifecycle management. And thanks, Kevin, for the introduction. You showed some use cases we will see today. We will see the supply chain, we will see the BOM part, we will see even the marketing part, and all these topics Kevin has mentioned is something we take care of and we treat with our customers. So basically, to sum it up, we are an end-to-end transformation partner when it comes to your old legacy systems bringing into the new world. Last word on Aeroline, we are divided in several business lines. One business line, that's one I'm in, it's for engineering. There is another one for manufacturing and supply chain, and we have some others. And for sure, we have some selected partners here. Most interesting for today, for sure, Neo4j, but there's, for example, Mistral or NVIDIA. So that's the background. So now let's have a look at aviation. How many aircrafts are in operation today? It's almost 25,000 aircrafts worldwide. When we talk about aircrafts with more than 100 seats and freighter aircrafts, not taking into account military ones and the smaller ones. So it's an incredible amount already. But what is the forecast? This forecast is done by Airbus, but it's validated and confirmed by other independent companies as well. So forecast for 2044, so in almost 20 or 18 years, is that there should be almost 50,000 aircrafts in operation. So today, 25, in 18 years, 50,000. Out of those 50,000, there are 43,000 not yet produced. So meaning there is an extremely high demand on new aircrafts in the next decades and the next years. When you have a look at the order books in Airbus, there is more than 9,000 aircrafts in the order book, not yet produced, not yet delivered. It's roughly about $700 billion, the backlog. Boeing has quite same number, a little less aircrafts, but the same in dollar. This is the biggest backlog in all industries. There is no other industry with such a backlog. To compare it with Oracle, before there was graphs, there was other databases. Oracle has more than 600 billion, NVIDIA more than 500. So why do I show this? To demonstrate there is an incredible demand in building aircraft in the next years. So, and the main aircraft which is a cash cow in Airbus and which shall be produced is the A321. The single aisle family, the one with one corridor in the middle and 3 seats on the right, 3 seats on the left. That's the main one. And you see here the production footprint, the industrial footprint of Airbus in 10 so-called FALs, final assembly lines, in more than 20 sites of Airbus, and you see the worldwide footprint everywhere. So that's where Airbus aims to create and to build those aircraft. When you have a look where the turnover and the profit is generated in Airbus today, you see that exactly those A320 family. So the other aircrafts, A380, A350, they play a role, but by far it's the A320 with the cash cow. You see 3.8 billion of profit. You see the other aircraft. You see helicopters and defense and space. My colleagues over there, Jose, Alexander, you can talk to them regarding these topics. I'm more for the commercial aircrafts as I'm in Hamburg. Yes, and this is very recently published the day before yesterday. I found it in Wirtschaftswoche. So let's do a quiz. Imagine you want to lease or to rent an A320. Do you have a rough idea how much it costs, including the 2 engines you have, but without the crew? What does it cost per year? Does somebody have a rough idea?
600.
Sorry?
I mean,
Didn't get it.
no. 5 million? 6 million?
5 million, 6 million. Other ideas? It was not too bad. It's actually, when you take the long-term average across the last years, it's 2 to 3.5 million per year. It depends pretty much. On is it brand new? Is it already 10 years old for sure? And is it equipped with luxury items, or it's a more low-cost carrier? So, second question in this quiz. And the first one is including the engines. If you want to lease or rent these 2 engines only, how much might this be?
I think 1 million.
1 million?
I think 70% of the total.
70% of those? Any other ideas?
150.
We have figures from April this year. It's 4.8 million. So, and why is that? So because there's a huge scarcity of those engines, the engine suppliers don't get it up and running. So they have production problems, they have on their side supply chain problems as well. So there are not enough engines available right now, which has a couple of strange effects. One effect in Airbus is that in Q1 they have produced 142 aircrafts, and they could only deliver 90 because for the other 40 or 45, there was no engines available. So what does it mean? First of all, if you don't deliver the aircraft, you don't get paid for sure. So you have a cash flow issue. That's the first problem, but there are strange side effects. Like the employees of Airbus cannot park their cars anymore because you need to have those airplanes, you need to store them somewhere. You store them on the parking lots where usually the employees park their cars. Huh? So in Airbus they call those aircraft gliders because they can only glide and not really fly. So what does it show? We see a single component disrupts the overall very well established business case, and this is one topic in the supply chain. I did a very brief search about news with Airbus and supply chain, and all of these articles here are very very recently published, and you see there's the media is full of articles about it. So, but now let's come to the problem and the problem identification and solution with a graph. When it comes to engines, you can do the math with pen and paper, because we have 2 engines per aircraft. You don't need a graph to see what's going on. Maybe the engine suppliers or the engine companies, they might need a graph for their supply, but now I'm talking about Airbus itself. So that's not an issue, but there was another issue. I cannot talk about all the details because it's confidential, but close before Christmas, end of December, close before Christmas in December, a tier 1 supplier of Airbus was telling Airbus, okay, we cannot deliver a specific part because it's not available, we don't get it done. The same day, the second tier 1 supplier, so the tier 1 is the one directly allowed to deliver to Airbus, was calling, okay, we cannot deliver this part. Oh, it's the same one from the other. What's going on? And there was even a third one. So Airbus was in trouble because this was a necessary part for sure. We cannot build the aircraft without these parts. So they did an analysis, what's going on. And it took more than 3 days to find out, okay, there is one specific tier 2 supplier delivering to all those tier 1s. And it was a single source tier 2 supplier. And this was not assessed yet by risk assessments. They usually do for all the tier 1s, but they did not include the specific tier 2 supplier. So this took the first 3 days to find that out. And it took another 2 days, so a full week, to identify, okay, if this fails, what is the impact? What is the impact on which aircraft, in which final assembly line, for which final customer in the airlines? So we got to know this issue for the procurement and supply chain department in Airbus. And we directly thought, okay, this might be a good use case for Neo4j to identify with a graph. So we made a proof of concept I will show today. Before that, you see here below the different tools involved. You have an ERP system like SAP. You have not only one SAP, you have several SAP systems in the different sites and facilities. You have PLM systems. You have dashboards. You have maybe Excel. You have Google Sheets. You have whatsoever. Everything needs to be linked. Somebody needs to know all the details and the interrelations, the connections, the different data formats to find it out. So what did we do? We mapped all those pieces of information with this different tier level of the suppliers. And here as an example, we see again the issue. There is a sub-tier of a tier 1 not being able to deliver the parts. So what we can see now directly, we can see the impact. If somebody is failing, we can identify, and we for sure need to see how to count, what countermeasures to apply, what can we do, is there another supplier, tier 2 supplier, tier X supplier dealing with the topic. What you can do in addition is a kind of risk prevention activities. You can first of all identify in your supply chain, okay, how many single source suppliers do I have below my tier 1 suppliers? Usually this is done, but it's not done on all levels because of the very complex situation you have. So, and this was basically a brilliant use case for a graph, and I will show what we have done.
Well,
You see? So first of all, this is example data only, and that's quite similar to what Kevin already explained. We have mapped the data structure. What you can see here, let's zoom in. Just an example. You see the MSN, which is the aircraft itself. You see the program, which is, for example, A320, A380, A350. You see a so-called head-off version, which is the main aircraft when an airline comes and wants to have 20 or even 100 new aircrafts. The first one is the head-off version. The other ones are the rebuilds. So it's a very famous term in Airbus. You have the final assembly line. You have the assembly itself and so on. So that's what we did first. And to show you some example data, I go to the dashboard. And then you can directly see, for example, a summary. You see a specific part here, the carbon part. And you see directly, okay, for this part, it's built in those MSNs, meaning in those aircrafts. You can see, okay, in which final assembly lines is it done? It's, for example, here in Toulouse, Hamburg, in Mobile, Alabama, and even in China. And you see the affected suppliers, meaning in those tier logic, which tier is affected. You see here the more complex graph with all the interdependencies, and you can have a lot of, let me say, different insights into your data. We showed this prototype to the customers department, and they were very much impressed because this was directly solving the issue they had, and they would have saved this 1 week, and they would have seen it directly in the tool. One of the feedbacks was because they are not used to graphs. Okay, it's kind of complex and it's kind of complicated. Can you create something like a dashboard? So that's what we done. So here's an example for this dashboard. When you come to the office in the morning, you open this dashboard and you see directly, okay, there is a titanium fastener and there's an issue. And you see directly, okay, there is 10 aircraft affected with this fastener, and you can go into the details. You see, for example, here, this fastener is already built in aircrafts which have been supplied, which are already flying. So you wouldn't need to make a recall here, for instance. And you can directly see, if you want to make this recall, okay, this and that MSN, this and this aircraft is affected. And for sure, you see the ones in production and the ones which are planned. And here, in addition, which open POs, which open purchase orders are affected.
Right.
So that's the dashboard. One topic as an outlook, we have created a process mining topic with Y files from YWorks to see a heat map. So you see the flow here, the process mining flow, and you can identify, okay, if it's going red, it could be, for example, a bottleneck. So it's easily done, and you can use this for several use cases. So coming back to the presentation, where is it? Yeah, to sum this up, so we mapped the supply chain in a graph. We were able to identify the bottlenecks. We were able to identify these topics with a tier 2 supplier, the impact of the defective parts. And we were able, with Neo4j and with the graph database, to solve this issue very, very quickly and to see those critical impacts. So that's all for the dedicated use case. I want to present briefly what we have done together with Neo4j in addition. Roughly 1 year ago, we had a boot camp in Hamburg. So Constanze and a colleague from Neo4j in France were able to give a deep insight and a training for more than 30 people of us. So, and those 30 people now are certified Neo4j professionals. And one of those guys has programmed and installed these tools and these dashboards. So happy to do this. And this was a great success from my side, because our people were quite eager to get into the graph topics. They are professional developers, so they basically know what a graph is about, but they have not worked with Neo before. And now they can. That's a very good point. And we have a couple of other use cases and products in place. The most famous one is AirNavX. In Airbus, you have the aircraft maintenance manual. Whenever there is a defect in operation, you need to consult the AMM, the aircraft maintenance manual, and it's a huge bunch of paper and of PDFs. And it was always a pain to get through all those PDFs, and there are interconnections between PDFs and so on. In AirNavX, it's a Neo database behind. It's one of the biggest available, as far as I know. More than 20,000 users of aircraft and maintenance companies are using it. So it's really, really a big one. The first project my colleagues from Sopasteria have done together with Neo4j was the so-called INA, the Intelligent Network Analyzer for mobile networks, where you can see impacts. For example, if a mobile base station is failing, if there is a, I don't know, football, big event, what is happening? Do I need another node or do I need another base station, for instance? With BMW, we have created the engineering co-pilot, which is for requirements management. There is a link to the one we will see later today. And the final one I want to mention, because we are talking about supply chain management, it's Decade X. You may know Gaia X initiative from the European Union. It's about data sovereignty and data spaces and how to work together. And Decade X is the one for aviation. Our CTO from Supersteria is part of the board. The head of IT is part of from Airbus is head of the board. And we are doing several use cases, and we are doing use cases with Neo4j here as well. For example, for data conformity and other supply chain topics. And that's it.
Thank you very much. Anybody questions? We have a little bit of time. Questions? No questions?
Well, you might expect, limitations in regard of using knowledge graphs that you think this could be touched by knowledge graph.
Mm-hmm.
Or do you think the possibilities are really accelerating?
When it comes to knowledge graph, I mean, the situation.
Use cases.
Yeah, in this use case, what you would need to know, you for sure, or what Airbus is doing, they are doing kind of different assessments with its suppliers. There is, for example, and I was part of this group, the Technical Development Capability, TDCA assessments, to see if a supplier is capable of producing the parts, of engineering the parts, and so on. This includes the supply chain. There is other dedicated procurement audits and assessments to really identify and to see risks, because I mean it's not the first time they have an issue with the supply chain. For sure, they are going to their suppliers, try to help them and try to identify if there is any problem. But this is first of all for the direct supplier, meaning the tier 1 supplier, and it does not include necessarily the tier 2 and the tier 3 and so on suppliers, because there is no direct link and there is no direct contract. So this could be a limitation from a use case perspective, to see, okay, we are not even allowed to go to this supplier because it might be in another legal entity and it's a different company anyway. So from a use case perspective, this could be a limitation and would need to be respected in new contracts, because usually the contracts are very, very old. For the A320 program, which starts in the early 80s, there is partly contracts from the 80s, which do not include, for example, to hand over 3D and metadata. So Airbus cannot even enforce the suppliers, please give me your data. No, it's not in the contract. In the contract it's written we have to deliver a specific piece or part, but not the metadata.
Thank you again. Before